Good morning, Stockholm, or should I say, god morgon. All right. It's really funny. I had a colleague who came and worked in Sweden for a while, and he was like, wow, this is really weird. I don't understand. Everyone in Sweden is so nice, but you must really need coffee or something because first thing in the morning, what everyone does is come in and insults their colleagues. Insults their colleagues? What do you mean? Yeah, you come in and you say, moron, moron, moron. Yeah, okay. Anyway, I'm very, very pleased to be back here. For me, Stockholm is like home because I have managed to work here some during my career. But for the last, it's a little more than a decade now, I've been back in the US and working hard on trying to make Java better. In fact, we've made a lot of changes. So what I wanted to do today is talk about some of the changes and the results that we've seen from that. I did want to mention, some of you may have been coming here expecting to see my colleague Mark Reinhold. Unfortunately, he had an issue at the last minute and couldn't make it, so Matthias asked me to be here. I'm quite happy to be here, and I hope you'll be happy to hear what I have to say. So let's take a look back. Many of you have been working with Java for a while. Actually, let's see. How many people have been working with Java, let's say, since Java 8? All right, and then just keep your hands up. Keep your hands up. All right, let's go 7. So you can take it down if you didn't work with F. 6, 5, or I should say 1.5, 1.4, anyone? 1.3, 2, 1. Anyone want to say 1.0.3? There we go. I see a couple still up. So many of you have an idea of kind of the history. And so, when I say I look at the bad old days, you'll understand this in context. I'm not saying they were horrible. They were the best we knew then. They were all we had. But in many ways, they were the bad old days. And what I mean by that is this. We had a model of development of the Java platform that had really come from what we thought were the best practices for making software like that in the mid-90s, right? It took a long time to get releases out. They had lots of features in them. And this you can kind of understand because the pressure is great, right? The whole world uses this. You want it to be right, so you take a lot of time and care in order to get it there. But, there were a lot of problems with this, right? So one of the problems was generations of developers could come along and never see a new major version of Java and be like, yeah, do people still use that? This perception of Java as legacy. And so basically, when I went back to put the teams from the JRocket team here in Stockholm together with the Hotspot team in California and elsewhere in the world, basically we said, hey, we've learned a lot about how to do software engineering. Maybe there's a better way. Maybe there's something else we can do. If you look at this sort of bad old days, a really big challenge was because the releases were so infrequent, the incentives were all wrong. And what I mean by that is this. If you were working on a cool feature for the next version of Java, and the deadlines were coming along, and you weren't quite ready, the temptation was to say, I better put it in anyway, right? But it's not ready. Yeah, but if I don't get it in now, it's going to be 4 years until the next opportunity to foist this upon the world. Okay, what I mean, all right. The problem, of course, is that this is a very self-fulfilling prophecy, right? Why do you think it takes so long to get things out? Well, because things are going in that aren't quite ready. And we know this now. We know that software engineering is done better in smaller increments of change and faster cycles with more feedback. Now, this was not only bad for the people who were developing and putting features in. Of course, it was very bad for people who were trying to consume and use Java because, even when a new version came out, there was no sort of pressure or interest in taking it up. It often took 1 to 2 to 3 years until the libraries and tools that you needed actually supported a new version. And so this obviously was not good in a world that's moving faster, where you have choices, where there are other technologies. So we decided that we wanted to make a conscious effort to sort of turn the ship and do things differently. So the first thing that we did was we said, well, what is actually needed? What would be good? What could it look like? Well, developers want access to the new features we're making. Enterprises, on the other hand, want stability. It really shook down into sort of these two camps. And so we needed not only to come up with a way to get releases out more quickly with more features, but also at the same time find a way for enterprises to feel like we've got a stable base, we're not getting new stuff that's going to be challenging or cause problems. Our stuff in production can keep running, and it's going to be great. So how did we do this? Well, the model that we came up with and proposed a few years ago, we call now tip and tail. So basically what it meant was that we would do development on the tip, continually moving forward very quickly, and move from a feature-based model to a time-based model. And so basically, the time, next question was, well, how frequent is the time? We decided on 6 months. 6 months. So we went from theoretically 2, but realistically 3 to 4 years between releases to 6 months between releases. A pretty major change, right? And then on the other side for enterprises, we said, look, we're going to have a tail where we're not putting any of those new features into old releases, which was always the temptation before. Instead, we're just going to have updates to that in a long-term support mode that basically just patch things, make sure you're secure, fix any big stability issues or performance issues, but no new features. Well, I can say there was a lot of skepticism to this proposed change. And a lot of that skepticism actually came from the people on my team and elsewhere that work on contributing to the next version of Java. That skepticism came down to a few things. How can we possibly do it in 6 months? We've never done this before. The process overhead is tremendous for 4 years. It's going to be horrible for 6 months. What happens if we don't have anything to ship? Maybe no new features are done. Oh man, we're going to get overwhelmed by all those backports we need to do. And basically what this came down to was change is scary, right? It's always very scary to change how you're doing things and go into the unknown. I can say that it wasn't only the people working on Java that were skeptical, it was also you. It was the ecosystem, people who are using Java. One of those came in this form: Java 8 is all we'll ever need. And it wasn't that people thought it was perfect, it's that they thought it was good enough for what they needed today. Another one was, gosh, we're going to get overwhelmed by releases. There are going to be so many different ones. It's going to be really confusing. Another one was, wow, we're really concerned because, right now these releases come out every few years and the quality, when they first come out is a little shaky. So how's it going to be if that's happening every 6 months? Here again, what this came down to was change is scary. We're afraid of change. Okay, and I want to give you just a smattering of what we heard from folks in the ecosystem at the time. So these are real tweets. Most of them are probably still online, and you can find them. And this is by industry luminaries. This is by people who are well-known, well-respected, and they're kind of fun to read, especially now. I love this one. We can confidently say the new release cadence is bullshit. Okay, so let's go on. What happened? Well, we had a lot of technical challenges to get there. Some of these we had already been working on and gotten into place. I'm just listing them here. I think they're interesting to sort of know, but this is not really what I want to talk about because more than these technical changes, the harder change was actually cultural, right? So sure, you get a bunch of things in place, better testing, change how the repo structure is, simplify things, make changes easier, build in test automation, sure. But the harder thing here was changing how people thought about what they were doing. So this change of going from, I need to put it in because it might not make it, to, you know what, it's not ready, it shouldn't go in, there's going to be another opportunity real soon now. And a bit of that is also having confidence that this was not a change that was going to happen and then we'd sort of lose interest in a year. This was a change that was real and we were going to keep going with. So basically, main thing here was to try to keep the backports to a minimum, not backport things just because, but only because they really, really were required for something like security. Really, really buy into this idea that the tail was about stability, not shiny new features. We don't need to bring features to people who have said, I want to be on a release that's stable. If they want the new feature, give them the opportunity to move forward. I will say that we had to learn a lot about how to break down delivering features in giant, giant chunks, as we did, for instance, successfully with Lambdas, and break it down into things that are delivered successively, incrementally, over time, as we've done with pattern matching. Now, I will say an unexpected benefit here was that it turned out that doing things frequently, doing them on the same cadence at the same time, meant that the overhead of process was greatly reduced. We didn't have to replan releases all the time. Engineers were able to spend more time engineering and less time sitting in release management meetings. So this has worked out great, right? It worked out better than we possibly could have hoped. The releases have been coming out. We haven't missed a date. We have been seeing successive incremental smaller changes being made available to developers much more frequently. We've been able to reduce the overhead of backports and spend more time on development. We also were able to find that this faster cadence meant that we had an opportunity now to put features in a preview mode first so that people could try them out and give us real feedback from real-life situations, something that was very, very hard to do in the old model. Developers get more features. The enterprises have very, very stable long-term support releases. And it's very, very predictable, which is great for our industry. So have a look here. Everyone, as you can see, is now very, very happy, right? These are real tweets, again, from much more recently. I think they're from actually just about a year ago. I think it's continued to improve since then. And so, nobody has bad things to say. Everyone has great things to say. But as you can see, you can't please everyone. Wake me up when Valhalla's ready. Cool. OK, so what does it look like now? This is just a visualization. Most of you are probably aware of this. You can see the 6-month releases going on. The little red arrow says you are here. So 21 is out. We're about to come out with the next one. We've had several long-term support releases. Those are nicely overlapping. So for enterprises who want to choose when to move rather than go just because there's a new one there, that possibility is there. So, OK, well, what about this concern of we might not actually have anything to deliver? Well, if you go and compare these long-term support releases with previous major releases, which is sort of the equivalent amount of time, you can see that, in 21 itself, there weren't that many features added. But when we go back and look since 17, quite a few more. And since 11, which was the LTS before that, significant number of new ones. So this is really, really nice. Our perception is that the throughput has not suffered while we made the latency better. OK, so that's great, right? All of that is about the mechanics. Wonderful, we have this new release cadence. We have a way of getting things into your hands more quickly. But how do we actually decide what to work on? What is the thought process that goes into ideas for features that it makes sense to add to the Java platform? Well, my colleague Brian Getz will tell you that ideas are not the scarce thing. Plenty of ideas. He gets pitched, every day in and day out, about things that we should add. You just got to add this thing to Java. Often those take the form of a solution that we should just shoehorn in. And so the question that we always ask ourselves when someone says, well, why don't you just add X to Java, is, OK, great. Well, what problems does that solve? Who does that help? And above all, is there a way to solve that problem that is really, really sort of basic to how Java works that we can do that no one else can do? What I'm saying is we don't want to go around just re-implementing things that libraries could do. We want to do the things that really can only be done well in the platform. We want to add capabilities to the platform that let people write more libraries. Because if we do that, then you're, instead of going to having one way to do it, you may get 10 ways to choose from. And all that software gets better because of the competition. I will say that the bar is very, very high. We do want to make sure that things we're adding are really, really solid. And we're going to take the time that is necessary in order to make sure that's the case. We do have experience with things in the bad old days, despite the many, many years between releases, being put in that we then all have to live with over time that are quite painful. Serialization. OK, so we do try to understand the problems. we look for synergies. So this is another thing. We try to look for places where the thing we're doing is not just a point solution for one thing, but where the capabilities in different efforts are from different efforts basically help one another, reinforce one another, so that holistically the sum of the parts is greater than just each of those parts. Another thing that we do, I'm going to just mention this again, we really look at 3 vectors of change. One is changes in hardware that we want you to be able to take advantage of in Java, or for the Java runtime to take advantage of on your behalf. We look at trends in software architecture. So basically, if everyone wants to do microservices, are there things that we can add to the Java platform that make that more convenient or a better experience? And then a final one is new or interesting use cases where there often is a niche solution that is compelling. So I'm going to show you this as well. Obviously, we look at other platforms and what they're doing well, to find sources of things that people find compelling. And then typically, we don't just take those things and say, we're just going to add that to Java. We think through, what is the Java way of doing that? How can we do that in a way that feels natural to Java developers? Many of you may have experienced, from your show of hands earlier, the transition from pre-Lambda to post-Lambda Java. When Lambdas came out, there were people who came to us and said, these are amazing, they're intuitive, they feel so natural, they just feel like they've always been there in Java. What took you so long? Well, that's what took so long. If we had put the first version in, it wouldn't have felt simple or natural or like a part of Java. It would have felt bolted on the side. So we try not to do that. Here, when I talk about holistic things, I'll give you another example. When it comes to AI, a lot of people have come and said, well, why don't you just shove some AI into Java? What we've tried to do instead is think about what are the things that we can do that make Java a better platform for AI. And so we've looked, for instance, at Python, very popular for AI today, where mostly the libraries are sort of a thin veneer of glue that are calling some native code that's doing the bulk of the lifting. So basically we said, people chose to do that in Python because JNI is horrible. So we started a project to make JNI less horrible. That's called Panama. It's been delivering for the past few releases and is final with foreign function and memory API in Java 22. But we also said, why were those native things written in native? Why weren't they written in Java? And basically we said, well, AI is basically like giant gobs of data that you're trying to reason over, and that is difficult to do in Java because complex data is hard to represent. So, of course, people are choosing native for that. The reason for that is because Java started out with primitives, which are lightweight, and you can have lots of them, and they're fast to process with modern hardware, and objects, which are not, because they're very powerful. But that power makes them difficult to handle in large amounts. And so we started Project Valhalla to look at what can we do to solve that and make it possible to have much more complex data represented naturally in Java. These things tend to work together because if you're going to have lots of data, then in fact you have pressure on the garbage collector. And so we have projects like ZGC, which helps with that. I do want to mention, I'm not going to go into a bunch of detail on these projects. However, wonderful, wonderful talks at this conference, both by people on my team and from around the industry, about these projects in much more detail than I could possibly cover. So please go and listen to those if you're interested. OK, I want to mention this very, very quickly here. We're not only worried about you, this generation of programmers, we're also always thinking about the future and what we can do to make it so that the next generations coming along find Java interesting and compelling. And one of the things that we've noticed is that there's this sort of narrative, and it's not just a narrative, it's true, that Java is somewhat daunting to approach as a new student of computer science. So basically, we've been thinking about how to do this in a way that's natural for Java. Now, why is it difficult? Well, let's have a look here, right? This is probably the first program that a new developer will write, and it's full of boilerplate that makes people think Java is hard. In fact, you have to learn a number of concepts of object-oriented programming even to print "Hello World." And other languages have managed to do it with less ceremony. But here's the kind of comment that we hear. All right, we don't want them to jump off a bridge, right? So how can we make it easier? All right, well, let's go ahead and look at this, right? Paving the on-ramp in preview. So basically, we take this program and we look at what are some of the components that basically could be intuited for you and you don't really need. So let's see. We see that here there are quite a number of these things that can be removed, right? So let's see. We don't need the argument vector. If we're only going to have one class, we don't really need access control. And in fact, maybe we don't even need class declaration of visibility. The class itself, there we go. We don't need to know about this special package system.out. And so we can make this much, much simpler. All right, we probably don't even need the class name. And in fact, we can end up with a program like this. Now, we probably can make it even simpler than this once we've figured out, again, how to do it in a way that's natural for Java. And the important thing to realize here is we have not done this in a way that said, let's make a different dialect that's a beginner dialect. We've done this by saying, what are the concepts that we can intuit away, and how can we make it so that you only need to know about them when you need them, so that students can start with something simple and move to something more advanced. We know that it's not just about the language, it's also about tools. And so to that end, we have put out an extension for VS Code. We did that not because we think that's necessarily the best IDE, but because we know that for students, it actually is very compelling because they don't need to install something, right? They can just go to a website, they can run this. And for many schools, in that environment, it really works well. We also added something for you to be able to try out new versions of Java. So on the dev.java website, which is the site for developers, think about it this way. It's what some people think java.com is supposed to be. It's dev.java, right? So go ahead and look at it. This will allow you to test new features of the next version of Java, basically without installing it on your machine. Okay, so I want to just switch gears here a little bit and finish with talking about seatbelts. Now, I know that with the history with Volvo, this is very, very important and compelling subject in Sweden. Really drove much of the, no pun intended, safety in automotive industry. Well, when I was a kid, we didn't really wear seatbelts. We didn't think we needed them, but they were introduced, and successively, people were told you have to use them. And I think, now, many years later, nobody disagrees, right? Like, it was a good idea, we needed them, that's fine. So when we introduced modules in Java 9, we told people they were a seatbelt, not a jetpack. Okay, great. What? I don't see any jetpacks here. Why are we worried about these seatbelts? Well, the reason was that we wanted to be able to give you jetpacks. And we couldn't do that without actually having seatbelts. So we added those in, and basically, now that enabled us to move faster, both in the evolution of Java platform itself, but also for the library ecosystem. All right, so basically, what does that look like? Let's see why this is important. Of course, if you're writing a Java application and you're thinking about moving to a new version with new capabilities, remember they're coming in the tip, then it's not only your application that needs to move forward. In fact, what we hear from people is, my application is great, it's fine, I could move to 21 today. However, I'm using these libraries. Well, these libraries are actually all fine, but in fact, they're using libraries. And all that it takes is one library that hasn't moved forward, and now you have a problem, right? You can't move forward. And this is kind of a shame. We want you to be able to use the jetpacks. You'd like to use them. Library developers would like to use them. But somewhere in that graph, there's a library that has not moved forward, and so you're stuck. So basically, this comes under the category of yesterday's solutions or today's problems. Right? We've effectively made a solution that allows us to move Java forward faster and give you new features and better latency, but we've created this problem where libraries are facing a challenge, and their perception is, well, we got to make a choice. We got one version. We're going to do our newest version. Everyone wants that, even if they're running old stuff that's stable. That sounds very, very familiar, right? It sounds like the way we were thinking about 5 years ago. And so basically, my pitch here is, if we were able to change this for the Java platform, libraries can do it too. And in fact, you want libraries to do it because you would like new innovation on the tip, and you would like them to give you some kind of stable long-term support version. Okay, so basically, the suggestion is let's all work together in the ecosystem to get rid of this impedance mismatch. Let's find a way to make it so that libraries are moving forward and supporting new versions more aggressively, so you have that choice, if that's right for you. But at the same time, that they offer you some kind of stable updates on existing versions. Now, I know that if any of you are working on libraries, or maybe you're working on them internally, there's going to be a lot of skepticism to this. And it's exactly the same skepticism that we had. It's going to be difficult. It's going to be horrible. It's going to be impossible. It's going to be really expensive. And we thought it was going to be a challenge too, and it turned out to actually be a lot better than we thought it was going to be. And so basically, this is something where my view is that you as Java developers, in fact all developers, deserve a future where you get access to new innovation on a regular cadence that's frequent. You have the rich ecosystem of libraries that's out there, but they're supporting you in this rather than holding you back. And most importantly, you can choose the pace of change that's right for your organization and that's right for your application. And with that vision of a bright, shiny future, I'd like to say thank you and leave you with some resources that are available to you in order to hear more about new things that are coming in Java. Okay, thank you. Now, next, we have actually a little surprise. And for that surprise, I would like to welcome to the stage my colleagues, Sharath Chandler and Chad Aramura.
Well, good morning, Jfokus. Where's Chad? Chad, come on up here. Come on up here. So as George mentioned, there's a bright future ahead for Java. Here on the Java team, we take that future very seriously from an engineering standpoint, from a development standpoint. And I started my career on Java, as you can tell, a very long time ago, back in 1996. Never thought I would ever be working for the organization that's responsible for this impressive and powerful technology, language, and platform. But that innovation is not just from the engineering itself. It comes from you, the community. It's your interactions. And on Chad's developer relations team, one of our singular focuses is you, empowering the ecosystem, empowering the community to take that technology and spread that knowledge around the world. And there are certain individuals that have been carrying that water, cutting that wood, putting in the effort that is an extension of us here on the Java team. And it's important that we recognize those contributions. And today, we would like, on behalf of the Java team, provide a Lifetime Achievement Award. I think we all know who that is. He doesn't. Matthias Carlson, could you please come up here? Right this way.
Oh, shit.
Matthias, all we would like to say is you have been putting in that work, you've been putting in that effort. We've been humbled from afar seeing what you're doing, and this is just our small token and way of appreciation for who you are, for what you do, and how important you are not just to us, but for every person in this room. So this is for you. Don't spend it all in one place, but congratulations.
Oh. Yeah.
A few words?
Thank you. I don't know what to say, but you know, it's definitely not only me. So there's quite a large group of people that are helping me out with Joachim and Niklas and Helena and Jen that has been around for a long time, and Enno, and there is like shitloads of people that are part of this as well. So I would like to share that with them, and
As
also like the rest of the community.
Yes.
Thank
you, Matthias.
Thank you very much.